Number 25, write an equation for the straight line passing through the points 5, -4, and 2, 2. First thing to do would be to find the slope of this line. The formula for the slope is y coordinate minus y coordinate over x coordinate minus x coordinate. So that would be 2 minus -4, which is 6, over 2 minus 5, which is -3, and 6 divided by -3 is -2. So there's our slope. Then to write the equation, we can use point slope form with our slope and either one of these points. I just picked the first one. So we set up y minus the y coordinate of that point equals the slope times x minus the x coordinate of that point. So y plus 4 equals -2x plus 10, and then you could subtract 4 on both sides and get y equals -2x plus 6. Notice with that equation, if I plug 5 in for x, I get -4 for y, and if I plug 2 in for x, I get 2 for y. So it does work with those two pairs of numbers. Number 26, for f of x equals x squared plus 6x plus 9, first thing it asks us to do is find the vertex of this parabola. Well, we can do that by, well, the x coordinate of the vertex is -b over 2a. Here that would be -6 divided by 2 times 1, which is -3. And once we have the x coordinate, we can plug it in for x to get the y coordinate. So -3 squared plus 6 times -3 plus 9 comes out to be 0. So we get the vertex at -3, 0. Now another way to tell what's going on here is to notice that this x squared plus 6x plus 9 is equal to x plus 3 squared. So this looks just like plain old x squared, except that it has been shifted 3 spaces to the left, because in place of x, we have x plus 3. So the vertex, instead of being at 0, 0, is over here at -3, 0. And I didn't ask about intercepts, but that means that the only x-intercept is here at -3. The y-intercept you can't see here, but it's up at 9, because when x is 0, y is 9. The graph does look like this. It is a parabola. Its vertex is here at -3, 0. And does it have an inverse? Well, it does not pass the horizontal line test, so no, it does not have an inverse. You can't undo what this function does. For example, if you plug in -4 for x, you get 1. If you plug in -2 for x, you get 1. So we can't go backwards from 1 to, we don't know which one to go back to. It's not a one-to-one function, so we can't undo what it did. So the way to tell whether a function has an inverse is the horizontal line test. Here, a horizontal line could touch the graph at more than one point, so it's not one-to-one. It does not have an inverse. In number 27, we are working with the polynomial 2x to the 4th minus 3x squared plus 7x minus 114, and it asks, what are the quotient and remainder when this polynomial is divided by x plus 3? So to set things up for the synthetic division, we put the coefficients of this polynomial here, 2, and then notice there is no x to the 3rd power term, so there's a 0 here for the 0x cubed. Then there's a -3 for the x squared, a +7 for the x, and a -114 for the constant term. And if we're dividing by x plus 3, we put a -3 out here in front. It would be just a +3 out in front if we were dividing by x minus 3. But to divide by x plus 3, we need a -3 out in front. So once things are set up, bring down the 2. -3 times 2 is -6. 0 plus -6 is -6. -3 times -6 is +18. -3 plus +18 is 15. -3 times 15 is -45. 7 plus -45 is -38. -3 times -38 is +114. And -114 plus +114 is 0. So this last number, 0, that's the remainder. We got a remainder of 0, which means the division came out even. And the rest of these numbers tell us what the quotient is. The quotient is a degree 3 polynomial. It starts with an x cubed term because the dividend started with an x to the 4th power term. So the quotient is 2x to the 3rd minus 6x squared plus 15x minus 38. What is p of -3? Well, you could plug -3 in for x and do the calculations, but we already know the answer. P of -3 is the same as the remainder we get when we go through the synthetic division with -3 out in front. And so it turns out to be 0. So is -3 a 0 of this polynomial? Well, yes, it is. That's what this means. Number 28, if f of x equals 13x, x minus 9 times x plus 4 cubed, what are the zeros of that function and their multiplicities, and what is the degree? Well, notice we've got just an x by itself. That's like x minus 0. So one of the linear x factors is just x itself. So 0 is a 0. Notice if I plug in 0 for x, 1/3 times 0 times this other stuff is going to come out to be 0. So the number 0 is a 0. The number 9 is a 0 because of this x minus 9 factor. If I plug in 9 for x, then this part is 9 minus 9, which is 0. And when I multiply it times all the rest of this, it still comes out 0. And then -4 is a 0. Because if I plug -4 in for x here, -4 plus 4 is 0, to the 3rd power 0, times this other stuff is 0. So -4 is a 0, and that has multiplicity 3. We've got an x plus 4 times another one, 3 factors of x plus 4. So -4 is a 0, and then a 0 again, and then again. So altogether, counting multiplicities, there's 1, 2, 3, 4, 5 zeros, and 1, 2, 3, 4, 5 of these linear factors involving x. So the degree of this polynomial must be 5. If you multiply this all out, it would have an x to the 5 power term. Now, this is kind of the reverse of that. Give a polynomial with all real coefficients that has -2, 11, and 8 minus I as zeros in factored form. So if we want -2 to be a 0, x minus -2 or x plus 2 has to be a factor. For 11 to be a 0, x minus 11 has to be a factor. For 8 minus I, that number, which is a complex number, it's still a number, for that number to be a 0, x minus that number would have to be a factor. And then complex zeros occur in conjugate pairs. If we want 8 minus I to be a 0, then 8 plus I would also have to be a 0 in order for there to be no i's left when we multiply it all out. So that means that 8x minus 8 plus I is one of the factors. So here it is in factored form. X plus 2 times x minus 11 times x minus 8 minus I times x minus 8 plus I. For the parabola x squared plus 8x plus 7, what's the vertex? Well, the x-coordinate of the vertex would be -b divided by 2 times a. Here that would be -8 divided by 2 times 1, which is -4. And then the y-coordinate of that point would be, if you plug in negative 4 for x, you get positive 16 plus negative 32 plus 7, which comes out to be negative 9. So the vertex is at negative 4, negative 9. And then it's going to open upward from there. That's going to be the lowest point on the parabola at negative 4, negative 9, and then it opens upward from there. Upward because it starts with a positive x squared. To find where the x-intercepts are, we would take x squared plus 8x plus 7, set it equal to 0, and solve for x. So it turns out that the x's are negative 1 and negative 7. And notice that they are both the same distance away from negative 4, just in different directions. So negative 4 is right in the middle, and then because we have a nice symmetric parabola, it crosses the x-axis at negative 7 and at negative 1. The y-intercept, well, I kind of cut it off so you can't see it on the graph, but the point on the parabola with an x-coordinate of 0 would have a y-coordinate of 7. So the y-intercept, the place where it crosses the y-axis, is up at 0, 7. And the domain, that's what x can be, that's all real numbers. You can tell that from the function because there's nothing going on that would give you an error if you plug in any number, no problem with division by 0 or anything like that. If you zoom out enough, you'll eventually see a point on the graph for every possible x coordinate. But the range is from negative 9 on up. There are no points on the graph any lower than the vertex, which has a y-coordinate of negative 9. That's the minimum possible value you can get out of this function. So the range is from negative 9 on up to infinity. Now this is one of those piecewise defined functions. What it does with the number you give it depends on whether that number is less than or equal to 5 or greater than 5. So f of 4, well, it would be 3 times 4 plus 1 if 4 were less than or equal to 5. It would be 4 minus 4 if x were greater than 5. In this case, since x is 4, it falls into the first category. It's less than or equal to 5. So we do this to it. We take 3 times 4 plus 1, and we get 13. Whoops. For f of 5, well, that is still less than or equal to 5, so we're still doing this. 3 times 5 plus 1 gives us 16. For f of 7, 7 is greater than 5, so now we are doing this. 7 minus 4 is 3. Number 32, write an equation or formula for the parabola shown here. We start with f of x equals a times x minus h squared plus k, and we fill in the numbers for h and k that are the coordinates of the vertex. So negative 2 for the x coordinate and positive 1 for the y coordinate. So the function looks like some number, we don't know yet what it is, but something times x plus 2 squared plus 1. To find out what number has to go in place of a, we can pick another point on the graph, and I decided to pick the point negative 1, 0. So you can pick any point as long as you can tell what the coordinates are. So for negative 1, 0 to be on the graph, f of negative 1, when you plug negative 1 in for x, should come out to equal 0. So if I plug negative 1 in for x, negative 1 plus 2 is 1, 1 squared is 1, 1 times a is a. So a plus 1 equals 0, which means a equals negative 1. And now I know everything, and I can write my function as negative 1 times x plus 2 squared plus 1. Notice that if you just started with x squared, but then stuck a negative in front of the x squared, that flips it upside down. Replacing x with x plus 2 shifts it 2 spaces to the left, and adding 1 to the end shifts it 1 space up. So it does look like this.